Hello and welcome to Kubernetes and the Enterprise. I'm your host, Mike Bizarre, Chief Content Officer for the TechStrong Group. We have an awesome presentation today with a lot of panelists. We'll also be giving away some gift card later, and we will be encouraging you all to participate. So find that little chat button if you would, and as folks are talking along, we'll monitor what you guys are talking about and see if other folks want to jump in and get some answers. We have some awesome experts here, so let's get started. Our panelists today are Laron Heimovich, who is CTO for Rookout, a provider of observability.
A provider of dynamic observability.
Dynamic observability tools. Then we have Amit Sharma, who's Director of Product Marketing for Splunk. We have Mayor Curiel, Senior Product Line Manager for WhiteSource.
Hello, everyone.
And we have Itiel Schwartz, who's CTO for Commodore, a provider of a platform for troubleshooting Kubernetes. So we'll see what he has to say later. And we have Justin McCarthy, CTO for Strong DM, provider of authentication tools. And finally, we have Prashanto Cochavera, Director of Product for Kubernetes at Trilio, a data protection platform. Gentlemen, welcome to the show.
Hello.
Great being here.
Yeah, thank you, Mike.
It's great to be here, Mike.
Let's get started with Amit. Splunk is pretty close to what goes on in the enterprise. You guys are widely used as an observability platform. Are you starting to see a lot more Kubernetes in production environments? I feel like I'm a little too close to it sometimes. I've been following it for 5 years, and yet my sense is that most enterprises are still early stages. What's your thought?
Yes, they are, but the rate of change is astonishing. So before the pandemic started, I used to go to customer sites, talking to customers in EBC settings or just advising them on cloud native containers, Kubernetes. And they were like, every company had some sort of a team, right? Forward engineering team or some team is experimenting with Kubernetes and containers. But now that conversation has changed. Companies are adopting Kubernetes in production. And not only just they are using Kubernetes in production, and I'll give you a stat on this, right? So Splunk has tens of thousands of customers, and Kubernetes has emerged as one of the top 5 data sources that is ingested into Splunk. So that is huge. Second is not just people are adopting Kubernetes in production, but the number of containers they have in their production environment has increased, exploded. Container density has increased. How many containers they are running within Kubernetes orchestration per node, that has increased. Then number of workloads is continuously increasing. And the diversity of workloads that they are using, right? It's not just a stateless applications anymore. It is a stateful applications. People are running even databases on Kubernetes. So amazing traction that we have seen in so many data points at Splunk.
Yeah. Itiel, you want to follow up on that? Are you seeing the same thing? Or are there more people out there troubleshooting Kubernetes these days? And if so, is that driven by developers, or are we starting to see the IT operations people get more involved?
Yeah, I would say that the vast majority of adoption starts from the DevOps, or maybe not necessarily DevOps, but SRE. Because most of the heavy lifting of troubleshooting is on their shoulders in most companies. But the interesting thing that we are seeing is how developers are becoming the focal point for a lot of the troubleshooting process. And as the enterprise or as the company grows to be more mature, we see how certain people or even divisions that are the bottleneck of the troubleshooting inside the organization, usually the experts in Kubernetes, are trying to offload themselves out of this process and basically to empower or to shove developers to take more ownership, mainly because they can't handle the amount of work or they are simply bombarded with troubleshooting questions. So the most interesting thing that I'm seeing is how SRE are trying to shove troubleshooting to developers. Sometimes the dev are just bringing it on. Sometimes it's a little bit more tricky and a little bit more to do with the political hierarchy of the organization. So it's interesting to see the power shift between the SRE and the dev.
All right. Laurent, you're close to the devs. It seems to me, at least, they're having a bit of a love-hate relationship with Kubernetes. It's very complex and somewhat intimidating. They like the general idea of that. Is there some sense among the developers that they are getting excited more about Kubernetes, or are they still somewhat resistant?
So we're seeing a variety of things. First, I'm always surprised by we're seeing that over 80% of the workloads we're debugging are Kubernetes based. And that's even though our technology is agnostic. And if we're looking at that number, let's say 2 or 3 years ago, it would have been under 50%. And it's not only new accounts we're getting that are adopting Kubernetes, but also some of our older accounts are gradually moving into Kubernetes more and more often. So that's one thing. The other thing is that developers are, everybody, but especially developers, are lacking the tools to work with Kubernetes. Kubernetes is super powerful. It's the best system we have right now for running containers at scale in distributed environments, but it's also very, very complex. A lot of complexity that comes with that power. And especially for developers who are to a certain degree underserved by the open source community around Kubernetes, because that community is focusing very heavily on the ops people, on getting storage right, getting networking right, and that's super important. But at the end of the day, engineers have to be able to understand what their code is doing in those remote environments. They have to know what has happened, and they need to access that. And in many ways, the security paradigms around Kubernetes, which are great. We're going with GitOps, we're going with automation, we're going with CI/CD, but we are essentially locking the developers away from what's happening in those production environments. And it's critical that we give them the tools to access the data they need, do their jobs, to troubleshoot, to develop new features, to own what's happening in production.
Justin, do you think that people are intimidated to the point where it's slowing down development of these applications? And are people looking at all of this and saying, geez, I need a higher level framework to make this more accessible, and it's a certain class of developers that are writing in this platform, but maybe there's going to be phases here of development adoption based on where the tool sets are. What do you think?
Sure. Before Kubernetes, or even while Kubernetes has existed, we've had other types of abstractions. A lot of them have been cloud provider specific. I know among our customers at StrongDM, we provide access control to Kubernetes as well as other types of infrastructure. So we see a full gamut of different access patterns across sort of pre-Kubernetes, mature Kubernetes, post-Kubernetes. And I think everyone is reaching for some sort of abstraction, right? So if you don't see, let's say, a lot of intricate Kubernetes, you might see a corresponding high volume of Terraform that might be itself pushed down to teams, right? So that you can still shift left, but you're shifting left in terms of how you specify an infrastructure, and you just do more work in Terraform, for example. I would say in terms of what is the bottleneck for adoption, who knows? None of this is easy, no matter which tool you choose. I do often think about the sort of beginner and advanced use cases within Kubernetes. Like there's one set of use cases where, I wrote something, please just run it. Please just give me my own space. Please just give me my own URL so we don't clobber each other, right? So that's just run it. And I kind of also think of those as like the Heroku level of use case, right? Which is I just need an application running somewhere. There's a very different phase that teams eventually get to where you begin to need to say, please run it precisely like this. Please encrypt my stateful data in precisely this way. And actually, it's that part of real-world Kubernetes deployments, which I think I spend most of my time thinking about where that's going, because a lot of those implementation details need to be expressed in a cloud or platform-specific way. And how much of that you can shift left to your application developers, I think is an open question.
Correct. I would just add one more point to Justin's comment. Abstraction is definitely important to drive adoption, but at the same time, there are two distinct users of the Kubernetes system that we see. One is the developers and now the IT admins and ops. folks are also coming in. So the level of abstraction, how much you provide, depends upon what kind of user are you interfacing with. For example, if the same user is doing API-based stuff as well as the UI-based stuff, there is the user confusion piece that you need to maintain as well, ensuring there is consistency between both approaches. So that's one of the challenges that we deal with on a regular basis, depending on the persona that we are interfacing with.
All right.
I can share.
Mayor, there's been a conversation, or at least some sort of document floating around that describes a maturity curve around Kubernetes. Do you want to walk us through that a little bit? And, is that an accurate representation of the pace, or are people at all over the map and they're kind of jumping in on these curves wherever they happen to land?
So to add to the topic that to add a small comment to the topic before, one of the main challenges that I see that organizations have today is lack of knowledge. And the maturity model that you just addressed is one of the tools that helps us to bridge the gap. Kubernetes is an amazing platform. It's the way I see it, it's not just a platform. It's an enabler. It's driving DevOps. It's driving automation. It's driving application development and deployment and business goals for organization. But with that said, we have a lot of challenges to implement Kubernetes patterns and technologies into current traditional organization IT structures. So with that, we can leverage the Kubernetes maturity model that the CNCF has created for us. And this helps us to identify what are the gaps, what is my location of my organization in my digital transformation journey, and what tools I need to use, and what let's say mechanism I need to leverage in order to adapt to the current phase and to achieve to the current goals that I have. This is a great tool that I see that can be used also as an enterprise organization, but also as a vendor that's working with customers that will help us to identify what is the right solution that we need to provide to our customers based on their location on the digital journey, on the maturity model, sorry.
Amit, do you want to add to that? Because there is this larger conversation going on around observability these days, and people are a little bit confused about what the difference between observability and monitoring is. But do you think the complexity of Kubernetes may force that issue finally, where people are going to sort this out and think about observability more proactively than they might today?
Yeah. So if you think of complexity in Kubernetes, and Kubernetes is basically it arises from the distributed nature of Kubernetes. So if you just simply create a pod, right? Think about all the objects Kubernetes is creating behind the scenes. So you are just running a simple workload, but it is creating so many 50, 60 objects to support that workload. So the scale and distributed nature of those objects, they create a lot of complexity. Then you have a lot of layers, right? So we used to have physical servers and everything is running there. Now we have physical server and then host operating system, guest operating system, Kubernetes platform, container runtime, then your application, microservices, and things that they are consuming, right? Networking, security, storage, volumes. So that creates complexity and a lot of explosion in data, right? Every single thing is creating data, and you have to make sense of it. So in terms of observability and monitoring and observability, as you mentioned, so monitoring was, we used to know what things that we are going to have to monitor. So we will instrument and then we will monitor them, those resources. But Kubernetes failures can happen in so many ways. And that's a great resource we have. I would encourage everybody who's listening, Kubernetes failure stories. So it's a website that they are journaling the failure stories of different companies adopting Kubernetes. And it's a great way to learn from other people's mistakes. So failures can happen in so many ways. So you have to instrument, and you have to look at the system in a much more comprehensive way. And the system should be intelligent enough that you can ask any question or tell you proactively where to triage and troubleshoot if in case there is any problem with any of these distributed components. And finally, I would say, and these observability systems, if they can provide some sort of a directed troubleshooting, prescriptive way, right, where the problems can, because it can see all the data that is coming from the entire stack, that can help SREs and DevOps teams to troubleshoot in real time.
Itchiel, let me ask you this. Do you think that we'll get to the point where mere mortals can actually manage Kubernetes, or is it always going to require somebody who is an SRE level skill and we're all going to have to up level our skills? Or is there some hybrid between SREs and IT administrators that we can get to manage this whole play and make it feasible to deploy without having to hire an army of SREs?
Yeah, it's a good question because I don't have a simple answer, sadly. I think the complexity of Kubernetes is, even it looks like from above, oh, it is so complex. It is actually, there are like certain building blocks that are causing this complexity. And some of them I think will be solved in even the near future, which is like the infra level, the stability of the infra level. And I see GKE or EKS or AKS, they're doing quite a good job in handling the nodes and making sure the cluster is running correctly. Now there is what I'm not sure Amit I think mentioned, the fact that underneath everything there are so many objects that are just being created, which is like the ingress and the load balancer and the PVC and the PV, and like there are a lot of other resources. And I think some of them might be abstracted. Like going forward, maybe the abstraction will be so good, you won't necessarily need to understand everything in order to troubleshoot your application. And I think if I think about a service like S3 or AWS ALB, like it just works, right? I don't need to think about it. And I don't need to troubleshoot it most of the time, at least for S3.
Most of the time.
Yeah, most of the time. So I think some parts of the troubleshooting will be easier. I think the main issue that I'm seeing, which will be much harder to solve, is the amount of microservices, the connection between those microservices, and how they interact with your infra level. And that means that if you have 100 microservices that are talking with one another, it doesn't really matter if it's on Kubernetes or it's on serverless, or I don't know, bare metal EC2, it doesn't really matter. It is a very complex system, and it will be hard to troubleshoot it. And I think the good and the bad thing about Kubernetes is it made it so easy to have all of these horde of microservices and their interaction with the infra level. So to answer your questions, I think that some issues would be much easier going forward. I think some problems that we're currently facing will be almost invisible for most users most of the time. On the other hand, I see the rise of complexity with the inside app architecture and the app level to the infra level, which is the RDS queues and so on. And this complexity is only on the rise. I don't see it going down anytime soon. And I don't think we are even starting to scratch the surface of this particular troubleshooting or debugging problem.
Yeah, no, we've been focusing a lot on multi-layered observability, essentially about collecting the three pillars: getting logs, getting metrics, getting traces, getting infra-level logs, and aligning them and combining them with application-level logs, kind of getting the full picture. That's what observability has been all about for the past 5 years or so, as Amit mentioned. And as those are growing, we're getting a bigger picture, but we're also seeing that there is a limit to how much data we can collect. We can't add a log line for every code line. We can't run our applications in debug repository all the time. We can't sniff all our network traffic. And I think that's where we have to become more agile, not just of course, we can monitor, we can instrument, we must instrument. We should get the key metrics, the key traces, the key logs at all times, but we should also give our engineers, both SREs and software engineers, the tooling to adapt the data they're collecting on the fly to react to changing demands, whether they're trying to troubleshoot an incident, whether they're trying to design a new feature or to redesign the scale, whatever is happening, they have different needs and they need to be able to adjust the data they're collecting because we just can't afford to collect everything all the time.
Laurent, let me follow up on that idea for a minute, because we do hear about this notion of shifting left, right? We're going to have the developers run everything end to end. And I think there's some companies that have, a lot of money that can do that, and they're Netflix and guys like that. But can the average enterprise really do that? Or is it more about maybe we just need everybody to lean a little more left? Because it doesn't seem to me like the average developer in the enterprise has the time or even the inclination to manage all the operational stuff. What do you think?
So I think it goes back to the question of abstraction. Now, 20 years ago, we might have said a developer shouldn't worry about security or a developer shouldn't worry about quality, because 20 years ago, a developer would be worried about memory allocation. And memory allocation was a pretty big problem 20 years ago for an engineer. You had to allocate the right amount of memory. You had to make sure none of that was leaking. You had to worry about, keeping resources, number of sockets, number of file handles you were opening, tons of stuff. None of that matters anymore. We've gone to the point where we managed to abstract most of that. Engineers today don't worry so much about memory or sockets or anything like that. So essentially, we're freeing up CPU cycles from those engineers to handle more important problems for us. It's not enough that you write the code. Make sure the code is high quality. Make sure it's secure. And as part of that, we're giving them tools that to provide them feedback on the quality, automated testing tools, automated security tools. We're giving them the tools to use those free cycles to learn new topics and take more responsibility. Now, the more we make Kubernetes easier to use on the one hand, and the more we allow them to use higher level abstractions to build the application, the more they can take ownership of what's happening downstream in the value chain.
All right. Ahmed, let me ask you to follow up on that. Are there going to be two sets of observability tools, one for developers and one for ops? Or are they all going to look at the same data? What happens when we have the big meeting in the war room and everybody's looking at something different? So how do we bring all that together in some meaningful, actionable way?
Yeah, you know what? That was never the idea, right? You need one observability across everything that you're running. I think the siloed nature of this comes from Kubernetes is not a binary operation, right? So it's not like I have all the workloads right now in VM, and tomorrow or next quarter or next year, I have turned the switch and everything goes as we were talking about, Mira was talking about the maturity or the journey. So it's always going to be a journey. There will be diverse workloads. Every enterprise will have some they're running on premises, some they're running in cloud and EC2 settings or managed Kubernetes. So now you have different sorts of monitoring and observability tools, and that creates this, swivel chair effect, right? So you are using certain tools to monitor your on-premises or hybrid workloads, and you have the newer tools, observability solutions you are monitoring for Kubernetes or cloud native workloads. So that has to change because these workloads are interacting with each other. There is dependency. And unless you understand that dependency, your views will always be siloed. There will be blind spot. It'll take a long time, as you mentioned, the war room scenarios and finger pointing. So those sort of things, it's just going to take too much time. So observability tools are those that started in the cloud native world. They are evolving now to ingest data from and make sense of data from on-premises and hybrid workloads. So that problem, we certainly are solving that problem, right? So we are providing our customers simply like one place. The second thing that I see, which is more interesting, Leah, you talked about it. that there are developers' perspective and operations perspective. Developers who are writing the pod spec, who are creating Kubernetes-based applications, they have no idea how much resources it's going to take in production. So they are requesting everything in their pod spec. So they are asking for 10 core of CPU and 64 gigs of memory, just to be on the safer side, right? Their applications get all these resources. And when this gets into production cluster, Kubernetes reserve those resources for that application. So what you're seeing is resource utilization. It should have increased or improved. It is not. So a lot of Kubernetes clusters are running empty because developers are requesting a lot of resources, and Kubernetes is reserving that space. So that's something I'm seeing, which is interesting, which community will probably solve. And there are a lot of cost optimization tooling which are getting in.
All right. Developers are asking for infinite resources. I'm shocked. That's never happened before. Guys, do you think that as we go along here, and I guess I'll start with Mayor, are we going to see fleets of Kubernetes clusters? Because the original idea seemed to be that we were going to build a couple of large clusters and people were going to share them. But it looks like right now people are moving more toward a model where there's going to be maybe a handful of workloads running on an individual cluster. So do we need to prepare to manage Kubernetes clusters at a level of scale that maybe we weren't thinking about?
So the way I see it is that currently, as you define it, people are targeting and going for a big cluster. But for some organization, based on their business needs, they need to better prepare and better, let's say, align their resources. Because when right now, as you said, that they are building a fleet of clusters for the Kubernetes, they're just going to waste resources and they're not deploy, they're not going to leverage what they need to do. So it's mostly depends on the business goals, the way I see it.
I'll follow that one up, just because the majority of cases that we see are quite concerned with the security, and not just the security, but the compliance story. So being able to characterize this cluster as being subject to one type of compliance versus that cluster being subject to another, it turns out to be part of an important reason why we see fleets of clusters today. It's a pretty common pattern.
We see the same thing on our side as well. What we see is that data is created everywhere. So, wherever data is being created, whether it's edge, public cloud, your on-prem data centers, folks are trying to implement Kubernetes at that level. And then once you have multiple clusters where multiple sites of data that you own, automatic that fleet management and the compliance models that Justin's talking about fall into place.
Ilya, do you think that? Sorry, go ahead.
Compliance is obviously the number one reason, especially early on. But then you see other operational concerns creeping in, whether it's noisy neighbors, and you're worried about the performance or the availability of your application because of whoever is next door, and you're not particularly wanting to share or waking up in the middle of the night because the guy next door used too much CPU. And we're also seeing issues around how to manage, we're seeing issues around how to manage access to shared clusters. Who gets access? Can I give somebody else access to my cluster? And kind of it goes to, ideally we would automate most of that away, just like a developer shouldn't actually care about how many CPUs he's getting. He shouldn't care that much about, who is he sharing it. We need to have better isolation, and we need to have better secure by nature Kubernetes cluster. You shouldn't be tweaking around, making your cluster PCI compliant or HIPAA compliant or whatever the cluster you're getting from your Kubernetes provider or from your open source product should just be compliant with everything. And you should have decent capabilities to isolate workloads within the environments, both for resources as well as for networking. And today it can be very error prone doing those isolations, especially at scale. So people are just opting to separate those and kind of not worry about it, which is obviously not a good way to scale in the long run.
Ideal, do we need to reduce the number of knobs and things that people can turn on Kubernetes in terms of custom settings? Because it seems like where people get in trouble is they use infrastructure as code tools, they deploy this thing, they misconfigure this thing, and the next thing you know, there's an open port somewhere or something bad's happening. And so have we just made this too easy for people to make a mistake, and do we need to rethink what it is we present people?
I think like the majority of organizations, like the organization, are starting to build their own template mechanism in order to prevent developers to be exposed to, or like like super techie people to be exposed to like making mistakes and to like raw Kubernetes. I think that the rise of projects such as Backstage is like living proof that like the template mechanism, the fact that you can tell a developer, you don't really need to know all of these like port things. All you need to do is like click here, create a service, and that's it. And I think that we see the majority of the industry are going more to like more abstraction, less trust in like the developer or the less techie people. I think it has a lot of like really great benefits like Backstage and the templating mechanism. On the other hand, I will say that in Commodore, we see our users a lot of the time struggle because all of the sudden, like the load balancer is not working, or the port is, I don't know, is occupied or something like that. And they have no idea how did they get to the state that they are in. Like, what are all of these like magical objects that I didn't really know about till this moment that are having issues, if it's like Kubernetes service or endpoint or ingress. So I think we do see, I at least see that templating and the abstraction as the way to go for most organizations. I think it makes the development and the going into production a lot faster, which is great. On the other hand, it just bites you in the ass once you have a problem, and you really need to understand, or someone needs to understand, what the hell is really going on my cluster.
All right. Prashanto, is that getting more complex? You mentioned data, and it seems like there was this long-standing debate about stateful versus stateless applications being deployed on Kubernetes. We're seeing a lot more stateful applications for a variety of reasons, but does that make things more complex and more challenging? Because now I am trying to manage compute and storage on the same platform in ways that a lot of people previously tried to avoid.
Absolutely. When you think about any new technology paradigm, whether it was virtualization or cloud native architectures, data is the last thing that gets put in, because that's the most complex piece of the puzzle and needs much more careful attention. You normally bring in your stateless workloads because you have more confidence that, hey, these will just run. Then after that, you bring in more of your data or stateful applications back into Kubernetes. And what we are seeing, we recently had a webinar ourselves, and based on the polling, we saw almost upwards of 90% of users bringing stateful workloads. Either they're running 70 plus in production already, or they're thinking 20+% bringing their stateful workloads in. And it's a natural function is what we see, right? Eventually, you do want to have a architecture that you can solely be based on versus managing two different kinds of architectures. So with time, we will see this happen even more. From recent data points, we are seeing that push. KubeCon was definitely a event where we saw a lot more data related items happening, especially around, if you think about backup recovery, data management, compliance around the data aspects, scanning your data volumes for ransomware kind of pieces. So all those items, we are seeing a natural push and upward tick on those items. Is it early days? Definitely a little bit more on the earlier side, but the way the market is progressing, and ISV is providing different tool sets to manage their adoption, I see that happening very quickly in the near future.
Is anybody out there hardcore stateless only? I mean, data gets stored somewhere eventually, but the question is it going to be on the cluster or external? But is anybody among our panelists part of that crew that says, just stay stateless, it'll be easier?
So it's a matter of complexity. It's early complexity levels. You can often rely on your cloud provider to provide you with managed data services to a degree that's good enough for you. You can just get whatever SQL Server, graph database, NoSQL servers your cloud provider is offering you, and as long as you stay within their operating parameters, you're good to go. The thing is, with most enterprises, you're not that lucky. Maybe you have an old SQL engine that's not Postgres compliant, so you have to stick with it because otherwise you're going to have to rewrite your entire application. Maybe you need a database that's bigger than what a cloud provider is offering out of the box. Maybe you need a different kind of database, a graph database or a geographic GIS database, or anything that's off the standard grid. Once you go into those areas, then you're going to have to figure out what to do with that state. And as Prashanto mentioned, sooner or later, you're going to want to move it to Kubernetes because you don't want to have two different ways to orchestrate compute workloads.
Justin, you got anything to add to that? What are you guys seeing?
Well, I'll say we do have discussions. This is just internally about lowercase state and uppercase state. So state in terms of the authoritative backed up encrypted form versus, I guess, what you would call caches. Those end up being, of course, very different things. I did want to add on to actually the earlier discussion about whether complexity is increasing. I actually don't think that it is, and I believe the earlier example that Laurent gave about memory allocation. So essentially, if you had someone on the team, hopefully multiple members of the team, that could really analyze a problem like that, then you have this diagnostic scope where some members of your team can understand, let's say, the next layer down, in that case, the memory allocator, right? I think the key here before Kubernetes was to have some members of your team that could understand the next layer down. So as the application developers need to understand their application dependencies, so they need to work with members of the team that understood, perhaps how Terraform worked, perhaps how AWS worked. We're sort of we still need to exist in those same ratios. So you still need the same amount of expertise. The titles might be shifting, but we can all diagnose a pretty finite scope about what might be going wrong in a particular case, right? And so those scopes are shifting around, but the degree of diagnostic leverage is the same. It's just dealing in different topics. It's maybe no longer directly the Azure native API, and it's Kubernetes APIs instead. I don't see a shift. It's just a reallocation in terms of how we train and how we practice.
You guys agree with that? Anybody think the world is getting more complex and we don't have enough people and it's just spinning out of control, or are we just going to be able to kind of shift a little bit and a little more automation and we're good to go?
No, I agree that it's getting a bit complex because there are new technologies, there are new products that are coming out, and Kubernetes is growing. Every few months there is a new release. But as said here in this panel, if we just allocate the resource, if we just leverage current offering that we have over there in the market with vendors or services, or use the ISV's offering, so we'll be able to lower and diminish all the noise and all the complexity, and be able to provision applications and run the cluster with no problems.
All right, we'll see.
I think there are 2 points to this, right? I think from the ISV side, it would be abstractions that we would provide to make it easier for adoption. And then from the customer side, there will be automation. And that is the middle ground where Kubernetes would basically balance itself.
Exactly. And when the organization will grow his knowledge base, they can always shift off the services and manage it by themselves. But it's very important for organization not to try to do everything by themselves. Or let's say, okay, I was like a month ago in KubeCon, I saw this amazing thing that they did with Kubernetes. I'm going to do it in my organization. No, you can't do that. You saw someone from Commodore demo, give them a call. You saw someone from Trello, give them a call, and they will do it for you, and then you will accumulate experience and knowledge, and then you can maybe do it by yourself. But most of the failures and the complexity and the challenges, that the way I see it, and please feel free to add information, guys, is that people see all this cool stuff that we are doing with Kubernetes and said, okay, I'm a DevOps, I know how to code, I'll do it myself. Let's run. And they don't take under consideration a lot of stuff that they don't see, under the low-level layers. And if they will go with that approach, I think the market will see that it might be complex, but the challenge will be very lower.
Complexity is not coming out of technology. I mean, if Kubernetes were more complex than AWS, nobody would have been moving to Kubernetes from AWS. It would have just stayed with AWS. Complexity comes from business requirements. The world of digital is growing. Every company is hiring more and more engineers. Every department is relying more and more on the digital, whether it's for internal processes or external processes, system of engagement, system of records, and we're just aiming to do more. We have more engineers building bigger, more complex, higher scale systems. And that's where complexity is coming from. Kubernetes is not the enemy. It's not creating complexity. It's helping us manage it to a certain degree. But yeah, as complexity is rising because we're trying to do more, we need better tools so that we can spend our time where it's worthwhile.
All right. So famous last words is hold my beer. I'm going to do something with Kubernetes. And so my next question, of course, is, gentlemen, should everybody just rely on a managed service and focus their efforts on the applications and not get too deep into the bowels of the thing? Justin, what do you think?
I actually start a little bit from a different place, and I start from a team discussion where we're deciding what we're going to train on and what we're going to get good at over time. So 3 years from now, like, what are we all going to have some shared metaphors about, right? And if we decide those shared metaphors are going to be around that, like from a developer point of view, the Kubernetes, specifications of how we want to specify our applications will run, and from observability, here's the view into it, how we want the lens through which we want to see it. If it turns out that actually, like, how the nodes run, we don't care about, we're not going to really need to invest in that learning, then yeah, push that down to really any of the big names that can provide that service. Okay. So I think first, what do we want to be good at as an internal team? What are the vendors we're going to rely on, and which parts can we regard as maybe they're commodified or they're about to be commodified that we can push down to sort of just pay for it.
All right. Ideal, if people decide to go and deploy it themselves, is it your sense that they're deploying on virtual machines or bare metal, or just dropping it in the cloud somewhere? Where are we starting to see Kubernetes today, and where might we see it tomorrow?
I think there is like a big difference in where does the organization currently have his machines up installed. Like for a small startup, it's clear that cloud is the answer. They are not thinking about going like on-prem or running things on bare metal. On the other hand, I do see for a lot of enterprises or large companies that like bare metal and some hybrid approach is the way to go. And I'm seeing more and more like K3s and people trying to troubleshoot issues they have with their bare metal Kubernetes, which is super like tricky to understand and to basically to troubleshoot. But I think the majority is going to be in the cloud, and for big companies where it is much more lucrative basically to host it yourself, we are going to see a hybrid multi-cluster, some in the cloud, some on bare metal, and somehow they will talk with one another like in a good manner. I know that all the companies I talk with that are working in hybrid model are suffering quite a lot. So I believe like something need to change in this area, maybe with Anthos or with like other projects.
Yes. So just to add to that point, so cloud providers now are getting into on-premises Kubernetes, right? So in a hybrid way. So Anthos is an example. EKS you can run in multiple flavors. You can run obviously the cloud managed, AWS managed cloud native EKS. You could run EKS anywhere. which is you can run on premises, but AWS will provide support. And it is, by the way, the same distro that they are using on the cloud. You can run EKS on premises on Outpost. So you have your control plane on AWS, but your worker nodes can be on-prem, and you will manage it using cloud native tooling. Interesting anecdote. So there was a story on Kubernetes failure stories that a company they were using a monitoring vendor, and the monitoring vendor made so many API calls to the API server, so many calls that they brought the whole cluster down. So if you are managing your control plane, then you have to be really careful what you're putting in that cluster. So it's evolving continuously. It's getting better. Cloud service providers are providing on-prem solution. So I think the answer is everywhere, right? So people are adopting on the edge, on-prem, on cloud, and everything is getting better as the day every day goes on.
All right. Mayor, let me ask you this and shift a slight gear here, but I feel that once again, we have a new platform that's coming into the enterprise, and once again, security is a bit of an afterthought. We seem to always do this. I guess we can't learn from our previous adventures, but we're once again layering in the security on top of Kubernetes itself. The core platform feels like there's not much in the way of security capabilities initially. There's some APIs that people are layering in, but what is your sense of security right now? Because if I talk to security people, they'll be like, you increase the attack surface for what point?
Yeah, I agree. When Kubernetes is introduced to organizations, the biggest concern is that they don't know how to tackle and to address it. From one perspective, they don't know what they need to protect. The other, from another perspective, from another approach, they don't know how to protect it. When I'm looking at it, at security for Kubernetes in the enterprise, there are three main pillars that are required to be addressed. One is the support. We talked about just now about hybrid deployment, cloud providers, on-prem. So who's going to give us the support? Who's going to answer any security issues? Is going to be the cloud vendor? Is going to be the application team? Another topic that was covered here, but it's very related to security, is compliance. When we are deploying, we need to, based on your organization need, based on the use case that you're deploying, the Kubernetes cluster, you need to align to a specific compliance regulation, PCI, HIPAA, and so on and so on. And the last pillar that I'm looking is vulnerability management. So when we are deploying, we want to ensure that our configuration and the application is secured and free from vulnerabilities as much as it can. And usually when we are deploying a Kubernetes cluster, and that's what I saw, please add your input. There are a lot of shadow ITs in organizations that are deploying the Kubernetes cluster, and then they are trying to release their application into production, and then security blocks it. Because security was not involved from the day one, and there's a lot of stuff that are just some examples that I gave right now were not checked at the beginning. People don't loop in security at the beginning of the journey. And this is gave birth to the DevSecOps approach. So we have the dev and we have the operation, and we gave us the DevOps, and security needs to be looked in the early stage of the process. So we provide the guidelines for the developers to align to that guideline and move on in the pipeline. So if something that, one message that I would love to pass on to the audience, engage security teams early as possible when you're starting to plan your Kubernetes environment. Otherwise, it will hold back your deployment weeks, if not months. And I'm saying that this based on what I saw with customers in production environments.
I'll also add a few words there. So clearly at Strongium, again, we're all about access. So we're that entry point into the cluster. But what I also note is just because we deal with so many compliance sensitive environments, where I would say the history of asking about the story of the custody of any given byte of data when it's in transit, when it's at rest, certainly, and then even when it's in memory, right? So the isolation guarantees and the key handling guarantees that you inherit from one of the major cloud providers, they're very strong, they're very proven, they're very designed, okay? Depending on your case, you have to kind of find a way to map all of those into your Kubernetes story, okay? And then there's that tension. If it's great to imagine availability, it's great to imagine resources in terms of performance, but there's many cases where the flexibility of performance and the flexibility of imagining how to, getting very efficient use of some nodes from a cost perspective competes with some of those isolation statements, which were, on one hand, very easy to understand, let's say at the VM level, let's say again within AWS or Azure. So just if you're thinking about where's key handling, where's the use of cryptography in your system and being able to point to it all, it's definitely, we're just at the opening chapters of being able to feel great about the answers to all those questions.
All right. Does anybody feel like security is going to get easier anytime soon, or is this going to be a major issue we got to sort out?
I would say that
security is getting. Sorry.
Go ahead.
I was just saying security is getting harder first and foremost because there is a human opponent in the mix. You're not doing security for security's sake. It's not availability. It's not quality. You're not just trying to get it right. There is somebody out there actively trying to prove you wrong, whether it's for a white hat hacker or a black hat hacker. Somebody is out there proving you wrong, and they are often tenacious and financially driven. And it doesn't, in many ways, Kubernetes is great for security. GitOps is an awesome way to do security, to make sure you know what you have, reduce shadow IT, make sure you're following best practices, make sure everything is scanned and audited. Kubernetes in many ways is both safe by default and very easy to make even safer. But at the end of the day, security is hard because people are trying to make it hard for us because they're financially motivated to prove us wrong.
And I can add to that based on what we saw in the past year, container images and adversaries are making security a real challenge. Hidden malicious payload inside the container in a vanilla looking like images. Malware are being much more evasive. So the attack vectors are just getting, let's say the number is on the rise, and the actual attack complexity is getting worse from day to day.
Correct. And, we deal with a lot of migrations and stateful workloads and disaster recovery kind of items. So definitely, GitOps and DevSecOps are the, good themes from the deployment or the manufacturing of the application. But security is a 360-degree loop, right? So, what we have been noticing is there is also a security layer that needs to happen when you are migrating your applications, when you're doing disaster recovery of your applications, because there could be new CVEs and things that could have been discovered. So it is a 360-degree loop, DevSecOps from the instantiation of the app to the lifecycle of the application from a disaster recovery perspective as well.
All right. Amit, let me shift the gear and ask you a question about the future. We've been talking about this hybrid cloud thing forever and a day, and we have multiple clouds, but do you think at some point we're going to see standardization on the Kubernetes API to kind of provide that layer of abstraction that we need for hybrid? Or is it always just going to be kind of multiple clouds with different stacks running around here? Some are monolithic, some are microservices based, but we'll never get to this kind of unified API layer.
Yeah, I think that's people who are listening and who are watching draw the line in the sand that the basic premise of Kubernetes is portability, right? That it will work and look and feel the same no matter where you run it. And if cloud providers and vendors to start to put like bells and whistles on top of Kubernetes, and you are deploying on that, then you are getting logged in. So that's you're breaking that handshake that you did with Kubernetes. So you should always have native Kubernetes compatibility, and do not get locked down into any particular implementation of Kubernetes, which is against this native API standardization, because then we are just breaking the whole Kubernetes promise that containerization Kubernetes provides. So I think it's going to, but most of the cloud providers and vendors are adhering to that. They are providing vanilla native implementation, or if they are doing something, then they are contributing back to the open source Kubernetes.
All right. Anybody want to venture why it is that we seem to always get caught up in these little proprietary extensions when there's all these lovely little open APIs that you're supposed to stick to? Justin, any thoughts there?
For whatever reason, I keep thinking about this ecosystem as similar to how air travel works. So we all walk into an airport. We get on mostly either an Airbus or a Boeing, but then each one of those fuselages that we jump on has a very specific engine. You can't actually swap out the engine without redesigning the plane. Right, even though Rolls-Royce might be selling an engine to both, like you got to redesign the whole thing if you actually change that component. So I don't know. The proprietary extensions that I might be motivated to include. Yeah, I mean, just it helps you prevent throwing you out if you want to swap out the engine. It's reasonable. If I'm an engine designer, on the other hand, if I can just as easily get on an Airbus next time. So. A little bit of friction makes sense, especially if it gives some performance improvements. Yeah, I don't know. So I don't begrudge the attempt.
Laurent, what are developers thinking when they start using all these extra APIs? Is it just convenience sake, or did somebody just not tell them?
So at the end of the day, more often than not, there is stuff you need that's not yet in Kubernetes. Now it's been so much better than it was 5 years ago or 2 years ago, but quite often you're going to find that there is something you need that wasn't there. Let's say, for instance, when you started Rookout, you couldn't configure the timeout on the ingress for WebSocket connections. And that sounds small, except if you're using a WebSocket server, now all of a sudden you're doing flip-flops in the air to figure out how to configure the Google Cloud load balancer to allow timeouts that are long enough for you to have long-lived WebSocket connections. And you can have the same with how do you configure. In the past, you couldn't configure TLS certificates on the load balancer or other stuff. Now it's growing, it's improving, but it's never going to be complete. And as Justin mentioned, once you go dive in to the nitty-gritty details and try to do the more advanced stuff, you're going to often go into uncharted territory, away from the standard Kubernetes APIs, and either into the cloud provider stuff or other places that are not as easily, that are not as portable.
All right. Hey, guys, as promised, that hour flew by. I want to call out some of our winners for the gift certificates. They are Victor O, Diego G, Randy B, Cedric W. Congratulations all. Thank you all for spending some time with us. And to our panelists, thank you for sharing your knowledge and your expertise. You guys were awesome and outstanding as usual. And we look forward to having more conversations about Kubernetes on TechStrong as we go along. Folks, be safe and have a great day.
Thank you very much.
Thank you very much.
Bye-bye.